For the next part of section 2.3, we're going to move away from review and go into something that will most likely be review for most of you. I know this is sometimes covered in Algebra 2, but many times it's not. So we're going to talk a little bit about something called synthetic division. And synthetic division is an alternate way to do polynomial division. Okay, so one thing that's really important to note, this should be highlighted somewhere in your notes, this only works for linear factors, aka binomials, and it technically, well, it only really works when a is 1 on the binomial. You can do it in other situations as well, but it's not super useful, I would say. So let's go ahead and take a look at what I'm talking about. If I were to say divide 4x to the fourth minus 6x cubed minus 3 by 2x minus 1, notice that this is a binomial, but its leading term, that's what I'm calling a here, is not 1. So I would not recommend using synthetic division. Gets pretty messy with fractions in this situation, so if you don't mind fractions, you can go ahead and do it, but I would probably just do long division in this case. What I do think it's useful for is if we had something like this instead. If I said 4x cubed minus 2x squared plus x minus 2 divided by x minus 3. Now you might recognize this from a previous example, and so we will compare our final answer with that example. But notice in this case I have a binomial here. There's only 2 terms. It's linear, and my leading term is 1, so a equals 1. Leading coefficient is 1. So here's what you do with synthetic division. Your first step is to find the 0. There's only 1 of the divisor, or in this case the factor. And so if we were to do that for our example, we'd say x minus 3 equals 0, so x is 3. It's usually a pretty quick process. You just set it equal to 0 and solve. Next, what you do is basically it's just called set up the problem. And here's what this looks like. I'm going to take that 0 and I'm going to just sort of set it off to the side here. I'm going to put a little box around it. This is only necessary to differentiate it from the rest of it. You can put a full box, you can put a circle, whatever you want. And then what I'm going to do is take the coefficients of my original polynomial, the dividend, and I'm going to go ahead and write those down just kind of across here. So here's line 1. I'm going to leave a little space. So if you had lined paper, you might do this on 3 separate lines. Here's line 1, 2, and then 3. I'm going to erase that though, just so we don't get confused. You don't need those numbers. And we're going to go ahead and do the division now. So step 3 is to actually do the problem. To begin with, whatever the first coefficient is, you just bring it right down, kind of like we do with long division. And then you do 3 times whatever number you end up with down there. 3 times 4 would be 12. And that 12 goes right here on that empty space. Next, you do vertical addition, so -2 plus 12. That's what this line is here to represent. Would give me 10. 3 times 10 is 30. Go ahead, add 1 plus 30, I would get 31. 3 times 31 is 93. Adding these together, I end up with 91. And hopefully you do remember this from the previous video. This looks a lot like what we did before. You start at the bottom right, that's your remainder. And then moving up from there, you have 31. This is going to be x. And then this last one will be the x squared. So I usually start with whatever's on the very bottom right, just to recognize that that's the remainder. And then I figure out how many terms I have, and that gives me the rest of the answer. And so then I could write this out using the correct format, and that would be the solution. So regardless of whether you prefer long division or the reverse tabular / box method, you should get good at synthetic division when you have a linear factor. So one, you need to know when to use synthetic division. And you also just need to be good at doing it. You absolutely need to know how to do synthetic division. It just makes your life so much easier. This is so much quicker than the other algorithms. So just as another quick example, let's go ahead and do, let's say 2x cubed minus 7x plus 2 divided by x plus 2. Now I'm going to go through this one a little bit more quickly so you can kind of see what the process looks like and how fast it actually can be, and kind of see what you can skip and what you do need to show. So the first step I'm going to do is write down the 0 of the factor. I'm going to go ahead and write the coefficients. Notice there does need to be a placeholder because we don't have the 0x squared. I'm going to put the line down below. We'll go ahead and start doing this. 2 times negative 2 is negative 4. 0 minus 4 is negative 4. Negative 4 times negative 2 is positive 8. If I add those, I get 1, and then 1 times negative 2. So the remainder in this case is 0. That's kind of cool. And then my final answer would be 2x squared minus 4x plus 1. And we would be done. There's no remainder to include. I don't have to write plus 0 over x plus 2. Don't need to write this. And so we would be done with that. As you can see, this process does go quite a bit quicker. And that concludes synthetic division. This video was relatively short, really just focusing on synthetic division.